Hi, this is Kevin Trainer, and I'd like to welcome you to my lecture on Chapter 7 of the Murach's MySQL second edition. Chapter 7 is entitled How to Code Subqueries. I'm not going to read through the objectives, I'll leave those for you. Subqueries are a very flexible and powerful feature of SQL that allow us to sort of put one more level of indirection into a query. Most frequently, we see subqueries in where clauses. But the fact is, technically, you can have them in wheres, you can have them in havings. That's not too surprising because wheres and havings are really very close to each other in terms of functionality. You can have them in the select clause, and that happens pretty frequently. And you can even have one, although this isn't a common use case for me, in the from clause as a table specification. So this is a really general capability of SQL, and it's very powerful. So here we're seeing a subquery in a where clause, and let's look at what we have here. So we're selecting invoice number, invoice date, invoice total from invoices. And we're saying where invoice total is greater than, select the average of invoice total from invoices. What is interesting here for me is that typically in this kind of situation, okay, in the where clause, if we had an expression invoice total is greater than something. Now, the easiest thing would be for it to be a column name, right? Instead, we're coding a select in the parentheses. And it's not accidental that it returns one column, okay? Because we're comparing to a column, right? So we're comparing it to this column. All right? So pretty straightforward stuff. Very powerful idea. Now, it's possible to get the same effect that you would get with a subquery. It's possible to use an inner join. That's a plain old mom and pop join, right? It's possible to join things and get the same result. Okay, it's a matter of style. Okay, I'm not going to say that one is better than the other. It's probably a matter of how you think about the problem. Okay, so here's one where we're selecting invoice number, invoice date, invoice total from invoices joined vendors on vendor ID, where vendor state equals California, ordered by invoice date. Okay, so we did that with a plain old join. Or we can do the same query, not doing a join, but by using a subquery. So the select clause is the same, invoice number, invoice date, invoice total, from invoices, where vendor ID in, and now we have a select vendor ID from vendors where vendor state equals California, ordered by invoice date. So there are really kind of two ways of thinking about solving the problem. Um, I don't have any evidence that that the query when it actually runs is really any different, right? I don't have any evidence that one is efficient and the other is inefficient. Um, I would say that it's just a matter of how to express yourself. Um, as part of the course, when we're in this chapter, or when we say we want you to code a subquery, then we want you to practice that skill, right? So, um, we don't want to give you some exercise where you're expected to do a subquery and then say, well, I could do that with an inner join. Well, that's not what we want you to practice at that point. But apart from that, um, when you're a practitioner out in the world, um, I'm not going to recommend one over the other. Each has their advantages, and here's a way to compare them. Okay, a join can include columns from both tables in the result set. Okay, not not true of a subquery. A join is more intuitive when it uses an existing relationship. Okay, because it really comes from your kind of understanding of the logic and the relationships in your data model. Advantages of subqueries. A subquery can pass an aggregate value to the main query, and we saw that with average. So aggregate values, sum, average, min, max. A subquery is more intuitive when it uses an ad hoc relationship. So maybe you would be more inclined to do it if this wasn't a relationship that was maintained in the database using foreign keys. Okay, not a predefined relationship, formal relationship in the database. Long, complex queries can be easier to code using subqueries. And in fact, in the very end of this set of slides, we're going to show you a long and complex query and a methodology for how to break it down into a series of subqueries. Okay, so we're going to put our money where our mouth is there. Okay, so let's work on the syntax of a where clause that uses the in phrase. Okay. Um, so you can say where some expression is either in subquery or not in subquery. And again, the subquery pretty much is going to bring back a single column. Okay. So here we're bringing back, we're saying select vendor ID, vendor name, vendor state from vendors, where vendor ID not in, select distinct vendor ID from invoices. Okay. So it's not, so we're doing a vendor ID, so we're going to get back a column, all right, of vendor IDs, and it's going to be the vendor IDs that are in the invoices table. And the reason why we said we wanted the distinct vendor IDs instead of just select vendor ID from invoices is we get a shorter list that has the same values. It just doesn't have any duplicates. And it's going to be more efficient to do a query where the subquery is bringing back fewer rows in the result set. Okay? So the result of the subquery you see the vendor IDs that are in invoices, and then we see the result set that is based upon, I think we said not in, didn't we? Yeah, we said not in. So you can see that the vendor IDs in the results set are not in that list that came back from the subquery. And that's what we're looking for. Now, here's a way to restate the query that we just did using left joins. Okay. And I just want to point that a left join is an outer join. Okay. A left join is a left outer join. Okay. That means that we want all the values on the left side, which would be vendors. So we want all the vendors, even if they don't match invoices. Okay. So we have vendors left join invoices. Okay. What's going to happen in the cases where we have a vendor with no invoices? Well, then the vendor ID in the invoices table is going to show up in our result set as null. So when we do the select where vendor ID is equal to null, then we get the same result set. Okay? So if this is a case where we can get the same answer with the join, but because we're dealing with things that are not in the group, we have to result to an outer join. In this case, a left outer join. So here's the syntax of a where clause that uses a comparison operator. So we have an expression, where expression, then some comparison operator. And then we can say some, any, all subquery. Okay, so what we're trying to explore here is how does it add something to say some, any, and all? And it creates another level of power and sophistication that we want you to appreciate. Okay, so here is a query with a subquery in the where condition. So we are selecting invoice number, invoice date, the balance due. We have a formula for the balance due from invoices where invoice total, blah, blah, blah. So that's really balance due again. So balance due formula greater than 0. And invoice total and balance due formula again less than. And now we want to have some kind of aggregate. So we say select average of balance due. Okay. So we want a balance due greater than 0, and we want the balance due less than the average balance due. Now, why exactly you would want that in your business is a little confusing to me. I mean, you'd probably want the opposite, right? If you wanted a list for people to work on, I mean, typically what you want is you want some kind of list on who you're going to call up and encourage to pay, right? Wouldn't you want the people who owed you the most? Okay. Well, in this particular query, we're returning a list of people who owe us the least. So perhaps not well thought out from a business point of view, but from a query point of view, it makes perfect sense. And here is the result set. Okay, 9 rows. Okay, so what if we notice that we don't have, I just want to back up, we didn't say that the balance due formula is less than, we didn't say less than all, less than any. Okay, we said less than the average. Okay, so we didn't say some, any, all. We didn't use that option yet. Okay, we'll get to it. I just want to point out we didn't use it. Okay, so how would the all keyword work? Well, it's a little different depending on what the operator is. Okay, so let's work through all the entries in the table here and see if we can understand how it's going to operate. So on the left side we have the condition, okay, and on the right side we have some equivalent expression. Okay, so in this condition on the left side, we're not saying that we're going to code something like x greater than all parentheses 1 comma 2. No, we're going to say x greater than all, and then we're going to have a select, and we're going to have a subquery, and that subquery is going to return a single column, and it's going to be a list of values. So what we're saying here is, let's imagine that the results from the subquery brought back 2 values, 1 and 2. Well, what would be the equivalent expression? Okay, so this is a kind of a hypothetical. So if we had x greater than all 1 comma 2, it would be x greater than 2. It would have to be greater than the largest of the returned values. If we said x less than all 1 comma 2, then it would have to be x less than 1. It would have to be less than the smallest of the values that was returned. If we said x equals all 1, 2, okay, this would not be a well-chosen expression, because we would be looking for x equal 1 and x equal 2, which is by definition never true. Okay, so I mean, that's one of the, if you're looking at all the permutations that you could code, well, the expression on the left is a possibility, but the implication is that we're never going to return anything. And if we say the last one, x not equal to all 1 comma 2, it's the same as saying x not in 1 comma 2. Well, that makes a lot of sense. So of the 4 possibilities here, the first 2 and the last one are, sufficiently powerful. The one in the middle is just silly and not recommended. The third one. Okay? All right, let's look at a query that uses all. So we're selecting vendor name, invoice number, invoice total from invoices join vendors on vendor ID, where invoice total is greater than all. Okay, so it's going to have to be greater than all of them. Select invoice total from invoices where vendor ID equals 34. Okay, so we want all. So we want to look at all the invoices from vendor 34, whoever they are. And the subquery says we have 116.54 and another one 1083.58. okay? And we say that it's greater than all of them. So that would have to be greater than the biggest. So that would be, we're looking for something that's bigger than 1083.58. And let's look at the rows that came back. They're all bigger than 1083.58. So it looks like we got what we wanted. Now, who vendor ID 34 is, I don't know. Perhaps that's some kind of key vendor that we have. Maybe that's our best client, or maybe that's our, we think of them as the great comparison client, right? Oh, sorry. I always confuse this for accounts receivable. Perhaps these are the people who oh, yeah. I've answered my question from a couple of slides ago uh, about why we would want to look for the invoices that were less than the average. This isn't accounts receivable, it's accounts payable. Yes. And so I guess we're looking for things that are easy to pay. Okay, well, that makes a lot of sense. So my apologies to Joel Murach. Very thoughtful. My bad. Okay. Okay, so let's look. Yeah, so this one here on slide number 14. Um, Maybe vendor number 34 is our biggest vendor, right? These are the people who we buy the most things from. And so we want to know invoice total is greater than all the invoice totals. I don't know. There's some kind of a comparison. There's some kind of index vendor. Okay. Um, so we talked through all. Now we saw an example of all, and it worked out just as we thought. Now let's look at any. Okay. So again, we're not saying that we would code an expression just like the one on the left. We're saying that we would code an expression like the one on the left, and the list that we're seeing as 1, 2 would be coming back from a subquery. Okay? It's just what happened to come back. So if we say x greater than any 1, 2, then it just has to be greater than the smallest. So it just has to be greater than 1. I'm sorry, if it says it's x greater than any, then x just has to be greater than 1. If we say x less than any, then it has to be greater than the largest. It has to be greater than 2. If we say x equals any, then it's going to be the same as x in 1, 2. It's only going to be true if x is 1 or 2. And if we say x not equal to any 1, 2, we're saying that it either has to be not equal to 1 or not equal to the other. Now that's sometimes hard to wrap your head around. Okay, so if it was equal to 1, then it wouldn't match. If it was equal to 2, it wouldn't match. If it was equal to 3, it would match. Okay, a little hard to get your head around, but makes sense. So here's a query that uses any. Select vendor name, invoice number, invoice total. Vendors join invoices on invoice ID. Invoice total is less than any. Select invoice total from invoices where vendor ID equals 115. Okay, so again, I'm not sure why we pick vendor ID equals 115, but it has to be less than the lowest, right? So if we look at the result set from the subquery, the lowest value we have is 6. Okay. and we're saying that invoice total is less than any of those, where invoice total is less than any of those. Oh, I'm sorry. It's not the lowest. It's the highest. See, these are tricky. My apologies. It's a little early in the morning here. I'm still caffeining myself. Okay, so if it has to be less than any, what we're interested in is the largest. Okay, so let's look at the results of the subquery. The largest is 2567, so it has to be less than 2567. And you look at the final result set, and everything is less than 2567. So we got what we wanted. Okay? So I just want to point out what I consider the takeaway for these features is that these expressions are very powerful, but you have to really think about what you want. Okay? Okay, this is a query that uses a correlated subquery, and correlated subqueries are pretty darn cool. Okay, so let's just take a look at the query, and then we'll talk about correlated subqueries a little more generally. Okay, we're selecting vendor ID, invoice number, invoice total from invoices I, where invoice total is greater than, and then we say we want to select the average invoice total from invoices where vendor ID equal vendor ID. So we don't want the overall average. We want the average for that vendor. Okay. So we do the subquery. Okay. For that vendor. For number 95. So it has to be greater than the subquery value. So the subquery for vendor number 95 is 2850. So it has to be greater than, it has to be at least 2851. So we got 3 rows contributed to the result set from vendor ID equals 95. And the first one is 3270, that's higher. 3977, that's higher. 4621, that's higher. So we got what we wanted. But what's really cool is that this is a subquery that you can really think of having to run once for every vendor. So you can really think of this as a query within a query. So we do so this inner query is going on for each of the vendor IDs. Okay, so let's say that we have 114 vendor IDs or something like that. I think we have fewer than that. We have 114 invoices, I think. I forget how many vendor IDs we do. But what we're doing is that we're coming up with the average invoice total for all the vendor IDs that have invoices, and then we are comparing to those. So it's really the coordinated aspect of it has to do with the fact that it's on the same table, and has to do with the fact that we're going to have to do a comparison against this subquery for every row in the rows that are the candidates for the result set. Okay. The exists operator, pretty cool operator, pretty powerful stuff. So we can say where uh, where it exists subquery, or we can say we're not exists subquery. So what are we asking? Well, these subqueries, okay, are going to return a number of rows. Okay, here's in fact a subquery where we just say that we want to select asterisk, so we are selecting all the columns. Okay, not that we're going to do anything with all the columns, because what are we doing? We're counting rows. Okay, so if we get at least one row in the answer set, exists is going to be true. If we have 0 rows in the answer set, exists is going to be false. Okay, so we're saying we want the vendor ID, vendor name, vendor state from vendors where not exists. Okay, select all columns from invoices where vendor ID equals vendor ID and vendors. Okay, and what we're saying is that we want only those vendors who have no invoices. Okay, and how does that get measured? It gets measured by the number of rows returned in the answer set. Now, did we have to say select all? No, we didn't have to say select all. We could have just selected a single column. Okay, that would have worked out just fine too. But the question is, how many rows did we get back? Okay, 0 or 1 or greater. 1 or greater, exists is going to be true. 0, exists is going to be false. Here's a subquery and a select clause. So select vendor name, and then well, this is the first time we're really seeing it in the select clause. I'm thinking, yeah, it's true. Select the max of invoice date from invoices where vendor ID equals vendor ID as latest invoices, or is latest inv. Okay, so what are we getting? Well, we are in fact ordering it by latest invoice descending, so the latest invoice is up at the top. Okay, so we have the latest invoice for every vendor. Okay, and then we are ordering them in terms of how late they are. Okay, and when we say the latest invoice, this is a kind of invoice because typically you'd want to look at the invoices. Again, this is accounts payable. You typically would look at the invoices that had been hanging around the longest. These are people who are most likely to cut us off, right? So we would probably we'd want to order it the other way. So we'd want to see the because the latest invoice is the youngest invoice, and I think we'd want to see the oldest invoice at the top of the list, not the youngest. But who am I, right? The same query restated using a join. Most of these things can be restated with a join. In this case, a left join. And remember that left joins are outer joins. So a left join is a left outer join. So we're selecting vendor name max invoice date as latest in from vendors v left join invoices I on vendor ID. Okay, so we're going to get vendors. We're going to get all the vendors, whether they match or not, right? And we're going to get all the vendors, whether they match or not, and then we're going to get the max of the invoice date off of the invoices. And I think we're going to see nulls for the vendors who don't have any invoices, although you don't see any of that here. Okay, because we asked for a left join, so that means the table on the left can't fail. It doesn't have to match. So we're going to see vendors even if they don't have any invoices at all. So in that case, the latest invoice date would be a null. Okay, so we don't really see all the possible kinds of rows that we could get back here. Okay, now here's a query that uses an inline view, and we'll get to views at the very end of the course. But a view is a subquery that returns a table. Okay, so what we can do is we can create a table on the fly. Okay, now eventually when we get to views, we can find out that it's possible to save the definitions of these tables that we create on the fly, and we call them views. Okay, but if we're not going to save them, we don't have to name them. So what we do here is we concoct a table from a select. All right, and here's where you really see the power of relational databases, because queries, selects, always return a result set, and a result set can always be seen as a table. So you can do something as simple as say, okay, make up a special table for me, which is what we're doing here, and query that, which is exactly what we're doing. Now we're giving this an alias, and as I recall, you need to do that. I've run into problems when not giving a table alias to a subquery that we had in the from. Okay, that is perhaps something that would not be obvious. Okay, and whether this is a requirement of MySQL, I forget. Okay, that'll be a good thing for you to research. But if it's only a requirement for MySQL, but it is a requirement for MySQL for sure. Okay, whether you need to include characters for a table alias if you were using DB2 or Oracle, well, again, your mileage is going to vary. Go research that. Okay, so the sub select vendor state, vendor name, sum of invoice total as sum of invoices from vendors join invoices on vendor ID, group by vendor state, vendor name. Okay, so we're going to have vendor state, vendor name. So for each state, we're going to have a list of the vendors, and we're going to have a sum of the invoices. And then we say we're going to query that, and we want the max of the sum of invoices as max sum of invoices, group by vendor state. So we're going to pick the vendor who has the highest invoice total in that state. Okay. So here's the subquery: vendor state, vendor name, sum of invoices. And then you'll see that we've got 3 states. And let's see, in Arizona, we picked 662. In California, we picked 7125. In DC, we picked 600. We don't see the underlying row. And of course, we don't see all the rows in the result set. But that's how that's going to work. So what we have here is an example of using subqueries to simplify a difficult querying problem. Okay, so let's look at the subqueries that we have. This first one, it's in the from clause, so it's creating a view. Okay, it's creating a table on the fly, and we have a comment. It says invoice totals by vendor. Okay, and then it's joining another table. Okay. Which, I'm sorry, I somehow backed up. Top invoice totals by state. And top invoice totals by state is is selected from another query, another on-the-fly synthetic table, another view, invoice totals by vendor. So what is interesting here is that at the lowest level, we're figuring out the invoice totals by vendor, which we already know how to do. And then we are summarizing them to come up with the max within the state. Okay. And then we are joining that to the invoice totals by vendor. Okay. And then we get our answer. So we're saying that we're getting the top sum of invoices in the state, including the vendor name and the state. Right? So what's the takeaway here? Well, the takeaway from my point of view is that there are times when you want to take a query that is hard to express in its own right and break it down into pieces and solve it this way. Well, gee, how would you do that? Well, I'm glad you asked, because we're going to give you a procedure for this. So here's a recipe. Okay. State the problem to be solved by the query in English. Use pseudocode to outline the query. Now, pseudocode would be code that kind of looks like SQL, but it doesn't have all the finery, and it's kind of summarized. code the subqueries and test them to be sure that they return the correct data. This is a really important thing to do. So for instance, if we back up here and we look at the subqueries, we ought to be able to take this query and test it all by itself. Okay? And when we're getting exactly what we want, then we take another subquery that's a part of this, say invoice totals by vendor, and we convince ourselves that that's working right. And then when we finish that, then we use that within this outer query, and we make sure that that's operating right. So now it's just a matter of pasting them all together. All right. And coding and testing the final query. So here's pseudocode. Okay. So select vendor state, vendor name, sum invoices from, and then we just kind of use English. Subquery returning vendor state, vendor name, sum of invoices. Join subquery returning vendor state, largest sum of invoices on vendor state and sum of invoices, order by vendor state. And then of course, we code the first of the subqueries and test it. And then we code the second subquery and test it. And then we put it all together. All right, so this, I think, is a great example of how you can take problems that are a little bit bigger than you're thinking, right? Break them down into sub-problems and grow the solution a piece at a time. And with a little patience, you can solve some really challenging questions that you probably would not have been able to solve, which is trying to code the whole thing from scratch in some kind of intuitive way. You know, the easy things at this point in our SQL education, the easy things are probably pretty easy to just, you think of the problem and you code the solution. But harder things are not going to be that easy. So this is a great recipe, this one back here, for how to go at the harder questions that we need to answer. So I'll give you that to think about, and I'll say bye until next time. Bye-bye.